Today we're looking at the medians of a triangle. So a median is a line segment that connects a vertex of the triangle to the midpoint of the opposite side. So that would mean that there are three medians because there are three vertices and three sides of a triangle. So the three medians of a triangle do intersect. They do have a point of concurrency. That point is known as the centroid of the triangle. The centroid is located 2/3 of the distance from the vertex to the midpoint of the side opposite the vertex on the median. So here's an example of a median. You can see that it's connected to the midpoint of one of the sides, and then the vertex that is across from that side. You know that this is the midpoint because it does show that we have these two line segments are congruent. So the centroid would be located 2/3 of the distance from the vertex to the opposite side. So if I were going to approximate that on here, I'd say that's probably about right there. But if I truly wanted to find it, I would need to add in at least one more median. And to really make it solid, I'd go ahead and add in both of the other medians. And where they intersect would be our centroid. So our centroid theorem says the medians of a triangle intersect at a point called the centroid that is 2/3 of the distance from each vertex to the midpoint of the opposite side. So looking at our picture here, this one has all three medians drawn in. You can tell that they're medians because they show you that the two line segments on each side of the triangle are congruent to one another. Not necessarily to the ones on the other sides. But anyways, so J is a midpoint, K is a midpoint, L is a midpoint, and each of those is connected to the vertex on the opposite side. So the point where they intersect on this one is called P, so P would be our centroid. So if P is the centroid, then that would mean that AP is equal to 2/3 of AK. Now I want to take that over to the picture and have a look at it. So AP is from the vertex to the centroid. And the next statement says that that's going to be 2/3 of AK. So AK is from here to the other side. So the entire median drawn in there. That's true for all of the sides as well. So BP, so from here to the centroid, is 2/3 of the distance from B to L. And same for CP. CP is 2/3 of the distance from C to J. Alrighty. Okay, so for our first example here, they tell us that in triangle ABC, U is the centroid. So they're telling me this is the centroid. I want to pull some information out of that real quick. Since they tell me that U is the centroid, then that means that each of these, where they intersect, would give me a midpoint. So that would tell me immediately that I've got three pairs of congruent line segments. Then they tell me that BU is 16. So from here to here is 16. And the question is to find UK and BK. So let's start with our relationship here. So I know that BU is equal to 2/3 of BK. So from the vertex to the centroid is 2/3 of the distance from the vertex all the way across the triangle. So now I can fill in what I know. They tell me that BU is 16. So I'm going to put in 16 here for BU. Now I could solve this to find out what BK is. So to do that, I would start by multiplying both sides of this equation by 3. So I'm going to multiply this side by 3 and this side by 3 as well. That'll get rid of the denominator on this fraction on this side over here. So it gives me a problem that's a little bit easier to work with. So now I've got 2BK on the right is equal to 3 times 16 is 48. And now to solve for BK, I just need to divide both sides by 2. So that would give me BK on the right, and that would equal 48 divided by 2, which is 24. So this is one of my answers. BK is 24. The other question they asked was to find the length of UK. So for that one, I'm going to need to use a different theorem. And my other theorem here is the segment sum postulate from way back. So I've got this full segment here, BK, and I know that I can make BK by adding its smaller parts. So I could say that that's the same as BU plus UK. Oops. There we go. Okay, so now I could fill in whatever I know. So from my previous work there, I know that BK is 24. And BU was given to me in the original problem, so that's 16. And UK is what I need, so I'm going to leave that as just UK. So all I'd have to do here is just subtract 16 from both sides of the equation. Let's say minus 16, minus 16. And then perform that arithmetic, and I would get 8. So UK is equal to 8. And that was the other piece of information they asked me to find there. Alrighty, so now we've got a guided exercise here. I'm just going to read through it with you, and then you're going to pause the video and see if you can find all of the pieces that they're looking for, and then come back and see how you did. So it says in triangle ABC, U is the centroid, and AU is 16, BU is 12, CF is 21. Now just to be clear, CF, that's the entire length of the median here, from the vertex to the opposite side. And then they want us to find each measure. So you're going to find each of the ones that they're asking here. So pause the video here, go ahead and find all 6 of them, and then come back. Okay, welcome back. So you should have gotten UD is 8, EU is 6, CU is 14, AD is 24, UF is 7, and BE is 18. If you missed any of those, you need to pause the video again, go back and visit the centroid theorem, and the previous example. Maybe you could even rewatch the video for that previous example, and then come back and see if you can figure out why the answer is what it is. All right, we have another guided exercise problem here. It says in triangle CDE, U is the centroid, UK is 12. So getting familiar here, UK is 12, that's labeled on the picture for me. It says EM is 27, so this entire median from E to M is 27. And UD is 9, and that one again is labeled on the picture. And then they want you to find all of these measures. So once again, pause the video here, and then find each of those and then come back. Alrighty, so JU is 4.5, EU is 18, CU is 24, JD is 13.5, UE is 18, and MU is 9. Okay, for this last one, this time we're adding in a little bit of algebra. So I think I'll do one of them with you, and then I suggest you pause and try the other 2 on your own. So here we go. The first bit of information they give me is they tell me in triangle ABC, G is the centroid. So G is my centroid. So once again, that gives me a whole lot of information. That lets me know that these 2 segments are congruent. These 2 segments are congruent. And these 2 segments are congruent. It also tells me that BG is 2/3 of the distance of BD from the centroid theorem. And that's true for each of these. So AG is 2/3 of GF, and CG is 2/3 of CE. So my first bit of information is that GD is 2x plus 3. So looking at my picture here, GD is 2x plus 3. And it says BD is 33. Okay, so let's see, what I would know from this. Okay, so I'm going to do a little work off to the side for this one. So what they gave me was the smaller part of this segment here, and then they gave me the length of the whole segment. So I'm going to have to use a couple of theorems together. So one of the theorems I'm going to use is the segment addition postulate. So BD is equal to BG plus GD. And the other one I'm going to need to use is the centroid theorem, which says that BG is 2/3 of the distance BD. Okay, so now, in order to figure out what to do with this, I'm going to go and look at what information I have that I can plug in here. So I've got GD. I've got something I can put in for GD. So I'm going to go ahead and underline that one. And I've got something I can put in for BD. So I'm going to underline that one everywhere it appears. So the one that I don't know is BG. So I'm going to have to use these two things together in order to find BG. So I think I'm going to start with this one right here. So they tell me BG is equal to 2/3 of BD. So I can put in, oops, that was entirely the wrong thing. So I can put in what I know. I know that BD is 33. So I can say BG is equal to 2/3 of 33. So now when I multiply 2/3 times 33, I would get 22. So I get BG is 22. Now I can take this back and I can put it in here in order to find, I'm going to put 33 here and 22 there. And then for GD, I'm going to put in 2x plus 3. So here we go. So I've got 33 for BD. I've got 22 for BG. And then that's plus 2x plus 3. And now I just need to do a little algebra to solve. So I'm going to start by combining like terms here. So this would be 2x plus 25 equals 33. That was using the substitution property of equality. Next, I would subtract 25 from both sides of the equation. So that's using the subtraction property of equality. So 33 minus 25 is 8. And then I would use the division property of equality. So I'm dividing both sides by 2. So that would give me x is 4. Okay, and that was the first thing that they asked me for, find x. So x is 4. All right, so that took a little bit of maneuvering in order to find that information. I had to use things from way beyond, way long time ago, up to the brand new information from today. So you're going to do the same thing for part B and part C. In part B, you're finding y. In part C, you're finding z. And pause the video and then come back and see what the answers are. Okay, welcome back. So part B was pretty straightforward. You should have gotten y as 8. Part C was not quite as, well, it was pretty straightforward too. But part C, z is 2. If you have questions about any of these, make sure you mark them. Think about them again later, but then if you still have questions when you come to class tomorrow, that would be a great time to ask and we can discuss those.